Hey guys, welcome back. This is the second part of resolution of forces in engineer mechanics module 1. In this video we'll be doing examples from question number 6 to question number 15. So let's get started. So the first question here is, determine the resultant of the three forces acting on a hook as shown in the figure. So it is the what we need to do here is that we should consider this thing as a hook, and there are three forces acting in different angles. So before doing this we should draw a diagram. So there will be a force like this, which is 70 Newton. Then there will be a force like this, which is 80 Newton, and here we'll be having a force like this, which is 50 Newton. This is what they're saying. Even though the forces are from this side, it is actually originating from here. Okay, then only we can resolve these forces. And they are saying that this angle is 25 degree, and this angle is 25 degree, and this angle is 45 degree. Okay, so for this will give you a clear understanding. This figure will give you clear understanding now. Now for the horizontal forces will be 70 cos 50. Why? Because the angle between 70 and 80 is 25, and 80 and the horizontal axis is 25. So the angle between 70 and horizontal axis of course will be 50 degree. So we should take it as 70 cos 50. Then we have 80, it will be 80 cos 25. Then we have 50, which is 50 cos 45. So if we take these angles, then we will be getting a value. Similarly we can find the vertical forces, which is 70 sine 50, 80 sine 25 minus 50 sine 45. We'll be getting another value, and if we take the resultant and alpha, we'll be getting these values. Okay, I hope you understood. Now let us move to the seventh example. So here we are given forces of 15 Newton, 15 Newton, 20 Newton, 25 Newton, 35 Newton and 45 Newton act at an angular point of rectangular hexagon towards the other angular points as shown in figure. We need to calculate the magnitude and direction of the resultant force. So these we are given 5 forces: 15 Newton, 20 Newton, 25 Newton, 35 Newton and 45 Newton. They act at an angular point of a regular hexagon. So this is the angular point. Okay, and here we are given this angle is 30 degree, this angle is 60 degree, this angle is 30 degree and this angle is 30 degree. We need to calculate the magnitude of the direction of the resultant force. So it's just simple that now we have these forces. Actually we can draw this like, here we have the horizontal axis, here we have the vertical axis, then we have forces like 25 Newton this side, then we have 20 Newton this side, then we have 50 Newton this side, then we have 45 Newton this side. Okay, then we just need to calculate the solution and we'll be getting the values. There's nothing challenging in these problems, but once we go into deeper and deeper sections, these will become a small part of the problem, and in that case if we have any doubt in these problems, then only it will become a big problem. So in the next problem we are given two forces acting on a body are 500 Newton. Two forces acting on a body are 500 Newton, 1000 Newton as shown in figure. So here we have 500 Newton, then we have 1000 Newton. We need to determine the third force R such that the resultant of all the three forces is 1000 Newton directed 45 degree to x-axis. So here we are given a figure. It is saying that we are given three forces which are like, there are three forces from the origin. One force like this, another force like this. Actually this is not the resultant force, okay, this is just a variable R. We are naming the third force as R, okay. Then we have a 1000 Newton force like this, then we have an R force like this, and we have a 500 Newton force also like this, okay. Now what they are saying here is that we need to find the third force such that the resultant of all the three is 1000 Newton and is directed to 45 degree of x-axis. So actually this part is the R resultant. This is R. This is R, which is at 45 degree to x-axis. So what it is given here is that if R is given 45 degree to x-axis, 1000 Newton is 60 mm, 90 degree. No, it is not 90. It is 60 degree to x-axis because 15 degrees here and 45 degrees here. Then we have 500 Newton, which is 30 degree to x-axis. We need to find the third force such that the resultant of all the three forces is 1000 Newton. So the resultant, there is a 1000 Newton force like this, which is the resultant of all the three forces, and it is at 45 degree to x-axis. Okay, it is at 45 degree to x-axis. If it is at 45 degree to x-axis, we are now having the value of R and we are having the value of alpha. So what we will do is that we will just use the formula again. We'll be getting two equations and then equate those two equations. Show you here we'll be having fh, which is 500 cos 30, r cos 45 and 1000 cos 60, because here it is given that the third force is 45 degree to x-axis, okay. And if we do that, we'll be having an equation. Force on the vertical direction also will be having another equation, and we know that alpha is 45 degree. So alpha, tan inverse of alpha is equal to 45 degree, means tan inverse of uh, 45 will be 1. 1 is equal to Fe by Fh. So we will get Fh is equal to Fe, and we'll just equate these two equations and we'll be getting the value of R. This is the third force. Then yeah, you will be getting the third force. Okay. Now let us move to the third example. Figure shows four forces: 8 kilonewton, 10 kilonewton, 20 kilonewton and 2 kilonewton acting at a point O in the same plane. We need to determine the direction and magnitude of the resultant force with respect to the reference axis. So this is our figure. Is by now you will be able to actually do these problems, because it's nothing but the same symbol problem, but in this case these directions have interchanged, because Now these are pointing towards the origin. Actually, it should have originated from the origin, but in this cases, these have are pointing towards. So first we need to make these forces concurrent, that is in this form. Like if we are having these forces, it should be like this. Then we should have another force like this, and so on. Then only it will work. So we'll interchange these forces like this. Now we will find fh, then we'll find fv, then we'll find resultant, then we'll find alpha. Okay, it's nothing but it's simple. So in this case I'll just it will be fh will be equal to 20 cos 30 plus 2 cos. Actually we don't need we'll put this kilo in the after part. Okay, then only our problem will be simple, or else it will be a lot of math and all. There will be a lot of zeros. Why to care of that now? 20 cos 30, then we have minus in these two directions, so we should put minus 10 cos 60, then minus 8 cos 45. Okay, so we have got fh value. So if we solve this problem, we'll get fv also like this. Then fv, then we can find r, then we'll find alpha, and so on. Okay, so we'll be getting minus 8.4 kilonewton, 12 kilonewton, and rs 14.65 newton kilonewton. um, there will be a lot of calculations in these kind of problems, so I would recommend you to have a scientific calculator all the time. You don't need to do these math problems all the time, because if you are doing it like that, then your most of your time will be spent in doing these calculations only. So I would recommend you to do these problems in scientific calculator, so that you just need to know how to do these things, and rest it will be easier. Okay. Now this is a very important concept which needs to be dealt with. Then only we can do the next problem. So if we are given a body like this, so in the case if we are given a body in on a wedge, this is called a wedge. This part, this is a wedge. Sorry. Okay, so this thing is called a wedge. Okay, and let us consider this to be a box, and this box is sliding in this direction. It is sliding in this direction. Okay, so if the box is sliding in this direction, we can have horizontal and vertical forces. This will be the uh, what we say, the horizontal force, and this will be the vertical force. You can interchange, you can have anything like this. or you can just have this as a horizontal force and this will be vertical force. It is your thing. What here we need to understand here is that the relation between this theta and this alpha, that is the most important thing. Then only you will be able to solve these problems. You should understand that fact. So let us consider, if this is a body, if it is a box like this, and it is sliding, and thing like this box is this wedge is nearby, then we'll be having two equations. We'll be having two triangles with a, here there will be a theta angle. Then if you are taking right angle, this will be 90°, then this will be 90 minus theta. Then here it will be 90 minus theta according to this opposite angles, vertically opposite angles. Then this will be 90 because it is right angle. Then here we have alpha. So in the case of triangle A, B and C, actually I should erase some part because it has become messed up. So I'll just erase. Okay. Now we are given in triangle ABC, we have 90 plus 90 minus theta plus alpha is equal to 180° according to the triangle law. Then what we here will be getting here is that 180 minus theta plus alpha is equal to 180. So here this 180 and 180 will get cancelled. Yes, so this and this will be gone, and we'll be having minus theta plus alpha is equal to 0. From that we'll be getting alpha is equal to theta. This is the most important thing which you should understand. Alpha is equal to theta and beta is equal to 90 minus theta, because here if alpha is equal to theta, then this total angle here is 90 degrees, so beta will be equal to 90 minus theta. So these two things are very important. Okay, so let us see the example here. I just wanted to tell you this because or else you won't be able to do this problem. This is a wedge and a box problem. Okay, I'll just take this aside. Okay, making it center. A system of forces acting on a body resting on an inclined plane is shown in figure. We need to determine the resultant force if theta is equal to 60, W is equal to 1000, N is equal to 500, F is equal to 1000, T is equal to 1200 Newton. So we are given all the things. So I'll just draw this. So we are given a system of forces acting on a body. So these are the system of forces acting on a body. So in the earlier video I have no in the earlier section I have told you that the angle between this theta and the alpha angle here, I mean this angle, yeah, I have told you that this angle is called alpha and it will be equal to this theta. That is alpha is equal to theta. That means this angle is equal to 60°. If this is 60°, what we can do? We can just guess it that we can resolve these forces into two components like this and like this. Yeah. If we resolve these forces into two components, then we can simply do this problem. So it will be like here we have the box. So the forces now will be like here we have the box, then we have the normal force like this, then we have the tension force like this, then we have W cos 60 which is like this, then we have F plus W sin 60, because here we have a force like this and we have the another force like this which is the component of this force which is in this direction same as the force. So we'll be adding F plus W sin 60. Now what we need to find is that we need to find the resultant force which will be happening. So what we'll do here is that we don't need this n and w equals 60, we just need this t and w and this direction. What we'll do is that we just take t minus f plus w sine 60. So from here we'll be getting the resultant value. So here we have the f parallel, so it will be t minus f minus w sine theta, and if you do that we'll be getting 233.97 Newton. And if you want, you can resolve the perpendicular forces. Of course, it will be zero because there's no vertical movement in this problem. It's just the sliding part. Okay, so it will be zero. So if you take the resultant, of course, it will be 233.97 Newton. Okay, now we have example number 17. Okay, so we'll be having one more problem. I know this video have become too lengthy, but you should be with me, solve these problems, understand it, make the best use of it. I'm just a college student like you. I'm just doing this to help you guys, and also for me. Do consider subscribing it and also liking my video, because it's a lot of uh, I'm just using a lot of time to make these videos, and I have very limited resources also, so do consider subscribing it. So here we have an example number 11. The three forces acting at a point are shown in figure. This is our figure. I'll just scroll down. So what are the three forces? This force, this 300 Newton force, then this 300 Newton force, then this 500 Newton force. This is not a force, okay? This y is not a force, it's just the uh, what do you say, the axis, and here we have the another axis, okay? And here we are given 30 degree. This is our theta, okay? So three forces are acting. The direction of 300 Newton force may vary. What they are saying, that 300 Newton forces may vary. That means this theta is varying, but the angle between them is always 40 degree. The angle between them is always 40 degree. We need to determine the value of theta for which the resultant of the three forces is directed parallel to BB. We need to determine the value of theta for which the resultant of the three forces is directed parallel to BB. That means this resultant force will be having an angle of 0. That is what they are saying here. Okay. So what will we do here? Just pause this video, think for 5 minutes, come back, and we'll just do the problem. First of all, we need to understand a fact that if the resultant of the three forces is directed parallel to BB, that means uh, this is 30 degree. Okay, we need to understand here is that the resultant of y direction should be 0, because it is completely on BB, which is the horizontal axis. So everything here will be on the horizontal axis, so the resultant on the y-axis or the FV should be 0. So we know that if we resolve these forces, we'll be having 300 sine 40 plus theta is one force, then we have 300 sine theta is another force, then we have 500 minus 500 sine 30. If we take this minus like this in this manner, and if we will equate it to 0. So when we do that, like 500 sine 30 is equal to 250. 250 divided by 300 is 0.833. Now we have got this much. Now we'll use the trigonometric rule of sin A plus sin B. Sin A plus sin B is equal to 2 sin A plus B by 2 cos A minus B by 2. So here A is 40 plus theta and B is theta, and if we put these values here, we'll be getting 2 sin 20 plus theta cos 20 is equal to 0.833. Now we have the value of cos 20 and 2, and if we divide 0.833 divided by this values, we'll be getting some value. Then after that we'll take sine inverse of that, then we'll be having 20 plus theta is equal to 26.32. From that we'll get theta is equal to 6.32 degree. Okay, so that is all for today's video of resolution of forces. I hope you understood my videos. Thank you for watching. I'll see you in the next one.